Welcome back everyone. Thanks for watching the previous video on the RS6 intake development. I know that went on for quite a long time, which is why we couldn't add on the prototyping section to that video, so it's now a separate video. Before I go on, if you haven't seen that video, please do go and watch the first installation of this RS6 development, which will lead you nicely to this video. We had a few comments in the previous video as I looked at the stock airbox, commenting on how poorly designed that intake was and why on earth Audi didn't make a better flowing system. I did mention this in one of my Yaris videos, and I'll just reiterate. I mean, I can't speak on behalf of Audi, but usually OEM manufacturers do not use the airbox for full power. They don't develop an airbox to give maximum output. The airbox is there mostly as a noise attenuator. So OEM manufacturers use an airbox to suppress sound, which is why you look at, for example, if you look at parts lists, they refer to it as a noise attenuator. I mentioned this in the Yaris video, is they look at NVH as parameters, which is noise, vibration and harshness, and the airbox is used to give the cabin, the driver in the cabin, less noise, less harshness from the turbo spool and the sort of engine noise, if you like, which is why a lot of stock airboxes can be very restrictive, but they're not too concerned about that because they will achieve a figure that they want, and the airbox is simply there to, like I said, attenuate noise. Good for us because then we can improve a lot and then open things up, and we like noise. So that's that. This video is looking at prototypes. So I'll be printing the 3D prototypes, fitting them, and then comparing side by side with the stock airboxes. So do hang around and watch the entirety of this video. So we've got the 3D printed prototype in front of me. You can probably see the lower airbox has some cracks along it. That's because we've been using it, and the brittle nature of the plastic has caused some cracks, but that's part of the R&D process, I guess. First impressions you should be able to see is that we have incorporated the slam panel with the lower airbox to make that volume as much as possible. And then obviously we've changed the lid completely in terms of its shape and size. If I remove the lid, show you underneath. So this is a custom filter we've had made by BMC, who are going to be making the production filters for this intake. It's a full cotton gaze filter, and it's got a good thickness to it. So it's not like an aftermarket filter for the RS6, which is quite thin and not a lot of filtration area. This has quite a depth to it, which allows us to maintain a good filtration area with those deep pleats in the filter itself. And then just put this aside. Okay, I'm going to just move the lower airbox out of the way for a second, and we just focus on the lid for now. Okay, so with the lid itself, we had several prototypes which we tested, different shapes, and we came down to this as being the best performing lid of the set of 4 that we designed. This was designed with airflow in mind. So there were other designs with higher volume, but they didn't perform as well because, like we showed you with the stock airbox, with that volume being almost cuboid shaped, it caused eddies and vortices in the system. So this is much smoother for airflow, and we've maximized where we can the volume. I'm going to put this side by side with the stock airbox. You can see the openings in the Eventuri are much bigger than the stock ones. And then if we look at the lid itself, you should be able to see, I'll put that below this one, the shape of the stock one is very cuboid in nature, as opposed to the one we've designed, which is a much better flow profile. We have verified with that with some CFD modeling to show a minimization of vortices in the lid. One important aspect to focus on is the overall design. So if I just bring the lower airbox back, We're going to look at the lower box in detail. I just want to show you something quickly first. So how this sits in the engine bay is roughly like that, and we've changed the angle of that panel filter as compared to the stock one. The stock filter sits very flat. It's pretty much at 90 degrees to the turbos, whereas we've angled our filter upwards a little bit, so it's not quite such an abrupt change in angle between the filter and then where it has to go to the turbos. If I try and put them side by side, you might be able to get a better idea of what I'm saying. So let me grab the stock one as well. You should be able to see that this ridge here, that's roughly where the filter is. So the plane of that filter is pretty flat there, and that has to then transverse to the turbos, which are at 90 degrees to that. So it's coming out of the filter and then moving pretty much 90 degrees straight out to the turbo. So there's a very sharp bend to negotiate, whereas we've angled our ones upward a bit. So you can see the difference in angle. So our filter sits slightly lower in the engine bay, which allows us to then bring the front up. So it's pointing more towards the turbos. So you get a less of an abrupt change. So it's more direct to the turbo rather than going in the front, up, and then out again. This is a lot more direct. Because we've incorporated the slam panel, the airflow opening underneath is larger. So it's not going through these two small openings like it does in the front of the stock one. I'll show you the base now. Let me take the lid off. Okay, so I'll leave the filters in place. We've incorporated the slam panel, whereas the stock airbox has to breathe from those two openings. Our one breathes throughout that whole section. I'll take the filter out to show you. Okay, so that's the difference in the openings. So we've taken it across the whole way, as opposed to just those two on the front of the lower airbox. So there's a much larger area to breathe from. Not only that, the fact that we've incorporated this section into the airbox means that we've been able to lift that upwards. So if you look at the stock slam panel, right, that's the stock airbox, and it's breathing from those two openings. Now, since we've incorporated the slam panel, what we've managed to do is, instead of that sloping downwards at such an abrupt angle, we've lifted that up. So this section on our one is now much larger inside. So there you can see the difference. Maybe if you look at it from the side. So where that's coming up straight, and those are the holes for the slam panel. If you look at the holes on our one, and it lifts up straight away, and it's got a curve to it. So the airflow is smoother, and there's more volume in terms of an opening for the filter to breathe from. This is why it was so important to redesign that lower airbox, because that is a restriction in itself. Okay, so moving on from the airbox itself, the final components are the turbo inlets themselves. So in front of me, I've got the stock ones versus the new designed Eventuri inlets. First off, the Eventuri ones have been made from a high temperature thermoplastic, and it's reinforced with CNC machined stainless steel bushes and a stainless steel ring on the inlet. So the reinforced ring is to allow the clamp to be tightened without distorting the plastic, and the bushes on the back are there to retain the tension between the bolt and the turbo itself. Now, straight away, you should be able to see a dramatic difference in the diameter of those inlets. The stock one on my left and our one on my right, which is your left. The difference is huge. I'm just going to quickly measure it to illustrate. So stock one is 53.5 millimeters in diameter, and the new one, our one, is 73 millimeters in diameter. Just in terms of diameter itself, you're looking at almost a 50% increase. Now, if you turn that into cross-sectional area, it's a magnitude above. So it's, in terms of volume, it's huge. That difference is huge. Now, on the back, they are the same. So since they both match up to the stock turbos, the diameter on the back is the same, which is very important, because if we made our one larger at the back, there would be a huge wall which the airflow would see and hit as it crosses these into the turbo itself. So it was important to get the back the same, but the front we have enlarged by as much as we possibly can, and the difference is huge. Same goes for the other side. Obviously the other side doesn't have the extra breather, but same concept. We've matched the back, and the front is significantly larger. Now, something which we've tried to keep throughout the whole system is that continuity of flow. Now, you can see that with the connectors. So the silicon connectors which mate onto the turbo inlets, you can see there's a step, an internal step. So that step mates onto this inlet, which allows the airflow to smoothly transverse through into the silicon without any internal step. So if I push this on, okay, so I'll open this up. Hopefully you can see that there's no wall being exposed now between the silicon and the turbo inlet. It's very smooth, airflow can go all the way through without hitting any barrier. I'll take this off again. I'll show you a comparison between this and the stock version. So let's start from the connection to the turbo inlet. It's huge. I mean, look at the size of that stock one compared to the Eventuri one. I mean, that can basically get swallowed. It's so huge. Importantly, the Eventuri silicon is smooth on the inside versus, as we showed you previously, the multiple ridges and change of direction and shape with the stock one. So I'll show you the inside. I've opened up to show you how smooth that is versus the stock one. And again, because we've opened the airbox up, the opening on the silicon is obviously naturally larger as well. So hopefully that shows you a very direct and clear illustration of the difference in size between the stock system and the Eventuri system. And I'm very, very confident that's going to have a dramatic effect on the performance of the vehicle, which is what we're going to do next. We're going to fit the system and then take it for a drive and do some testing. All right, now we've fitted the prototype system. First impressions is it's much more organically shaped. There's better curves, less cuboid shapes like the stock airbox was, much more optimized for flow. Obviously, the airbox is a different angle compared to the stock one, so you can see the lid has more of an angle to it. It's not sitting flat with these side panels, which is better for airflow because there's less of an awkward shift to the inlets. We've got the smoother silicons, which are larger, going into our larger turbo inlets to the turbos. Obviously, The lower airbox is now one piece with the slam panel. We've integrated the two pieces together, which has allowed us to then raise this section, which was on the stock slam panel, a chamfered, sharp edge. This is now curved, larger volume, bigger area for the filter to draw air in from. So the next step is now performance testing. And in the next video, we're going to show you the results of that. We're going to actually send this prototype out to some of our development partners, one of them being Eurocharge Canada. Slav's going to test it for us on his stage 2 car. We're also going to take one to Santapod, which is our local quarter-mile track. We're going to do some quarter-mile testing, which will allow us to also do some draggy testing with acceleration times. That would be great for real-world testing. We'll show you both of those in the next video, as well as the carbon final piece, which I'm looking forward to, because this looks good in prototype, but it's plastic. This can look amazing in carbon. So I'm really looking forward to that. So please join us for the next video and we'll show you what happens next.
Thank you so much for watching, guys. If you liked the video, please give us a thumbs up. And if you haven't already, please remember to subscribe to the channel and turn your notifications on. If you want to join the conversation, please drop us a comment below and we will do our best to respond to you. And if you're running out of things to watch, why don't you watch one of these two?